Thank you for coming to my session. I appreciate you guys choosing to come here over some other popular ones out there. This is a talk on understanding the basics of data analytics by visualizing the Drupal ecosystem. So it's a wordy title, but we're basically going to take some data and put some graphs to it, ask some questions, and see if we can come up with any interesting insights about Drupal itself. So I'm Leul W Shewangizaw. I recently became a data analyst, but also have a developer background. And show of hands, who's a developer, like has some technical understanding? All right, sweet. So it shows well. That's my GitHub. I'm still working on my social, so if you want to contact me, just feel free to email me. All right. So basically, data analytics gives us the tools to observe and react appropriately to reality. That's what it really boils down to. It's easy for someone to just talk and declare anything that they want, but at the end of the day, it's just words. Right? You're just trusting someone to tell you something, and you're taking that as fact or not. So this practice lets us get raw numbers behind anything that's going on. And for an example of that, what do you think about so the mortality rate in the U.S.? Do you think there's a difference between the facts, like what the CDC publishes, and what we perceive based on media or Google?
Yes.
Yeah.
Yes.
So this is an example of really good data visualization. So this shows you the differences in the CDC, Google search trends, and the media. So you can see here the media's got homicide as this huge chunk, but it's not even on the map when you look at the CDC's data. So data analytics just it gives the power to you to decide what's real or not. And then you can you'll make different decisions based on which one of these you believe.
Those are very interesting questions that you're phrasing with that too, because the criteria of the data you're getting will depend on the question that you're asking.
Yeah, exactly. What you search for. All right. So this information will be helpful to you if you deal with any kind of data. If your employer, if your organization collects, Google Analytics, they do a lot of that for you, but you can still make your own charts, ask your own questions. If you have simple or time-consuming tasks to do, Python has a lot of really cool automation tasks or automation tools. If you want to understand trends and position yourself for the future in any field, this will help you. If you want to convince people to do anything, it's easier to convince someone to change their mind if you have like a concrete argument. Oh, okay. And then before we move on, I wanted to tell you about my background. I got into this role because about this time last year, my life kind of got really crazy. I was freelancing at the time. I wasn't making enough to support myself. Things got out of hand. So I ended up moving back in with my parents in Charlotte. And for the last year, I've devoted myself to learning this field. I got certified in it in Charlotte. And a weakness I had was I would always focus on the idea behind things instead of what was right in front of me. So I chose this because I thought that would balance out, that impulse in me, right? So I'd rather just look at numbers and try to make decisions based off of that instead of this is how I think it should be because of a book I read or someone told it to me. And the session is going to be split into two parts. I'm a very hands-on. I learn best when I do and build something. So in the first part, we'll talk about just the theory behind it. I'll give you the basics for Python, the process, some of the tools that we'll be using. And in the second part, we're going to actually ask questions about the Drupal environment, pull some data, and we'll run some charts, some analysis off of that. All right, so we'll go into Python. Is anyone familiar with Python here? Okay, awesome. So it's ambitious. I try to teach you the basics of Python here in a few minutes. So we'll just break it down. If you're familiar with PHP, it's a pretty smooth, I would say PHP is much harder. Python's great. It reads and writes plain English, useful, all that stuff. And if you're not a developer at all, almost everything here you can do with Google or Microsoft Excel. There's formulas in that, pull in your data, you can do whatever you want. All right, so basics of Python. that's how you declare your variables. There's variable equals the strings. It could be a double quote or a single quote. When the basic types, you got strings, integers, floats, your true and false values, and then it's got a bunch of built-in functions. So to print something onto the screen, we'll just use print whatever's in those brackets.
Wait, with Boolean, you have to declare whether it's true or false?
Well, no. The Boolean values are true and false. I'm just putting that to a variable.
Oh, I got you.
Yeah. You got your arrays, your lists. So my list here, open brackets, list out your numbers. To get a value from your list, it's just open brackets. Uses 0 indexing, so it's 0, 1, 2, 3. 0, 1, 2, 3, yep. But when you call it by the index. To add to a list, you use the .append method, and you just brackets whatever you want to add. You can delete with del. And some very useful built-in functions. We got the len. So len prints out the length, however many items are in a list, or in an object, or whatever it is. You can do the sum, which is the total. Min and max are the lowest and largest, smallest and largest values. There's also dictionaries. So if you have something that you're describing, a car has, how many doors, walls, whatever. You can use dictionaries. Syntax is just curly braces and with a semicolon in between each thing. So here, programming languages, the name is Python. And we're going to add a difficulty of easy peasy. And we could print that out, and it shows you here, it prints out language, Python, difficulty, easy peasy. And we could also remove anything with .pop. Looping, so iterating in Python is really smooth. So for item in my list, item becomes how you refer to each item in the list inside your loop. So for item in my list, print item is going to print out our list. I had 1, 2, 3, 4, 5, so it's going to print out each one of those numbers. And then this is a string lateral here. I can highlight this. So right here, I can put a variable into my print statement.
Is that what that F thing is?
Yeah. So F, just F quotes, and then anything that you want to insert, any variables you want to insert, curly brackets inside. You can also create, instead of having my list, instead of creating it manually, the range function will create an array with however many values you want. So for I in range 5, it's going to create 1, 2, 3, 4. It goes 1 under it, and it's going to print each one of those values. And there's list comprehensions in Python to make this, so this and this are the same, or sorry, this and this are the same. So it's going to loop, so I for I in my list. So it's going to go to each item on my list, and it's just going to print it out here. So this is what you see here on the bottom.
So if you want to loop multiple actions, how do you determine the end of the loop?
Repeat that? Oh yeah. Python is strict indentation. So everything that's nested in here is within this loop. So you can loop infinitely. You just have to indent them correctly each time.
Got it.
All right. Conditionals. So if, and everything is done with semicolon here. So if the length of my list is equal to 4, print true. Else, print false. And I think I ran something else here. And then there's also how you compare different values, greater than, less than, and it's double equals for equals, and then not equal is exclamation equals. And there's also an in, so if 5 in my list, so it checks if 5 is in my array, 1, 2, 3, 4, 5. Print yes or no. So this is 2, 3, 4, 5 is my list. So if 5 is in there, print yep, which it did. This is how you define functions in Python. Def my function, and then put whatever's inside there. And then when you call that function with the open parentheses, does that. And when you put in a parameter, and we're just going to use that string lateral here, and it puts it in. So you call that with any name, and it's going to print that. Python has a pretty robust library of tools, packages. So here we're importing the time module, and it's got a bunch of different functions for manipulating and getting time values. So here we're calling time, local time, and it returns this object with the year, month, and everything about that, about the current time. So this is a little bit more advanced, but it's key for data analytics because it lets you bring in data and also run operations on it. So it's just a place, it's a way to store the data that you get from whatever source of wherever your data is coming from. So we're using the data classes, we're using a data class. So for this, in this case, we're creating a class called attendee with a name and how many years that they've attended this camp. And then there's also going to be a function that prints out an introduction for that person. So, and all that does is just, it's going to print their name, thanks for coming to DCA, you've been here for however many years. So I make a variable here called person, which calls this attendee class with Leul, and then 3, which is 3 years I've been to Drupal. And it's going to print, and you just call those values here with dot name or whatever I've created up here. And then person.introduction runs this function inside the class and prints out my introduction. So that's what you see down here. And for data analytics, these are some of the most common libraries that we'll use. Pandas for cleaning and analyzing data. Pandas is like the bread and butter for data. You could do, it's like Excel spreadsheets into Python that you can work with code. It's really nice. Requests in JSON for getting data from the web, working with it. And then Plotly and Matplotlib for creating your charts, your bar charts, line charts. It's got a lot of different options for that. And it's also got a library for machine learning. I fit machine learning in here, but it's a very rough example. We might not get to it, but you can do it pretty easily with Python. And that should be scikit-learn, actually. All right, so now getting into actual data analysis. There's 5, so I usually run through a 5-step process for analyzing data. So you always start with a question or like some kind of objective. You know, in the earlier graphic, we saw them answering a specific question or like telling a specific story. So once you have your question, you're gonna find your data sources, clean your data, analyze it, and then you can create your visualizations, and that's when you're handing that off to someone. If you're presenting it to your boss, employer, that's when you're presenting it to that end person. And it's advanced, but you can make predictions. You can start making models out of your data so that you can start like looking forward past whatever data set that you have. So when you ask a question, it could either be a question, a problem, like a specific problem that you want to solve, or a story that you want to tell about whatever your topic is. And this is really important because when you're looking at, you know, millions of rows of data, there's a lot of numbers. You can get lost in minute details in areas where you never need it to be there, right? If you don't have a clear objective in mind, and I guess anything, you get lost in the details. So this is just a way to keep yourself focused and get the job done. Finding data sources. Data is everywhere. I think this field really blew up because all these major websites, you know, we've created so much data in the past couple, like since technology, the more technology has grown, the more data has become available. So now we're trying to figure out what we can do with this data. Like what kind of value can we create with the data that we've collected over time? You know, what Facebook has got on all of us, what Google, whatever they've made. So the most common sources of data, APIs. Most websites have APIs nowadays. They make their data available to the public to make their own apps, to do research. There's data everywhere. A lot of websites, like government websites, will provide packaged data. So they'll give you a CSV or Excel file with a bunch of their data in there. You can scrape the web. Python's got a lot of web scrapers. So if no one is going to give you the data, then it's up to you to go and find the websites where your data lives, get it, and then put it into your own databases or your own Excel files. And you can also gather, it's not just digital, you can go and do surveys, you can make calls, gather data, you know, the hard way. And Kaggle.com is a really good resource for finding data sources. That you can just search almost anything, and they almost always have something. Google also has its own platform they publish data sets. They scrape the web for them, and they find data sets and make that available. Cleaning your data means you're removing all the things that you don't need. A lot of data sets are built by, a few years ago, there was like no real standards, I guess, so people just compile data, but they're not really checking for accuracy. There could be null values, they're missing some missing values. And then if you're getting data from like 3 or 4 different sources, the way that one data source names their columns could be different from the way that another one names their columns. So it's important to make sure that everything is uniform across all your data sets. Remove information you don't need, and combine anything if necessary. And what you're looking for is, from all the data sources, create one table that you can start running your analysis and your visualizations off of. Analysis here could mean a couple different things. A lot of the times you should just be able to glance at your data sets and kind of observe, where the anomalies are, what's going on in it. But there's also libraries for statistical analysis, and there's one really good one for stats. I'm not much of a stats guy, but the tools are there. I'm just noticing where the outliers are. And then in the visualizations, there's a lot of different libraries here that you just pull in your data, and it's going to create charts for you. You can export it in images or publish it to your website. And just an important distinction here, what I'm talking about is more, it's not enterprise level data. Like, this is like in the gigabytes of data. But once you get into enterprise, there's a lot more tools that build on these same principles. But if you're an enterprise level company, you're not going to have just one. Your data is so large that you can't just put it in one location. You gotta. A lot of these guys are on AWS or they're in the cloud, so you have to pull data from all these different servers and work with it. So there's tools, enterprise level tools that'll do it at the next level. But this is more of a foundation. And there's also tools for predicting the future. So machine learning in Python, it's probably one of the most popular frameworks for machine learning. So what I'm going to cover here is supervised learning. So this is when the data that you put into the computer is known, right? You're feeding it, here's X and Y, tell me the relationship, give me some kind of evaluation based off of that. Unsupervised learning, which is the higher level stuff, is when you just tell the computer, learn this stuff, right? You're not giving it any rules. It's just gonna learn for itself. And a really good example of this, they taught one of these games. You guys remember that game? It was like kind of like Pong, when you're supposed to break all the blocks.
Yes.
Yeah. I think it is like block breaker.
Block breaker. Breakout. Yeah. So they taught them. I think it was a Google program. They taught it how to play that game. And all they did was play this, and then it got the score. So it always compared, I guess, its performance to the score. And it got so good that it discovered a hack where if you send the ball to like the same place every single time, it like creates a little loop and it gets it the highest score possible. And with that kind of learning, it's like it does everything. It just learns from its own mistakes.
That's what they did with chess too. Is they just were like, here's chess, win.
Yeah. Same with Go.
Yeah.
What's up? Sure. Yeah. All right. We'll cover that. And the basic process for machine learning: you plot whatever data that you have into a chart. You look at your chart and you see which machine learning model would most likely fit that. So if your data is linear, and if we're moving upward over time, then a linear regression model would work for that. And you just put in your data, it builds the model, and then you can predict based off of that. All right. So that was the first section. Do we have any questions about some of the theory here? Anybody lost? Anybody bored? All right. All right, so let's move on to the second section now. All right, so now we're going to answer some questions about the Drupal ecosystem. So I played around with what questions I wanted to answer, and what I landed on was like what I've been away from Drupal for maybe 2 or 3 years now. I was in it for 2013, 2014. I left. I did some other mess around with WordPress, a little bit of Ruby. So I'm just now coming back to Drupal. So I'm trying to see like how's the health, like how's Drupal doing since I've been gone. So the first question I asked myself was, how's the user base of Drupal grown over time? And the data source here is the Drupal.org API. And the first thing I noticed is Drupal's like API services are amazing. Like the way that they structure data and make it available. Not like the JSON API is amazing, but even the Drupal.org API, the way that they store their users, they store every single node, every single comment of a comment, like everything is documented, going back to 2007, or 2001, sorry. All right, so the first thing we're gonna do is gather our data. So this is a Jupyter Notebook, and it's a data exploration tool for Python. So in a traditional code editor, you've got one page, and then you run your code, from the terminal, and it gives you the result, right? So Jupyter Notebook lets you execute code in blocks, or in cells, that's what they're called here. So I can create a variable here, Mike, and I could just run that. Print. All right, and then I can go down here and then go back and forth. So it's a living document, all right? I'm not limited. So it's really good for when you're exploring data sets. There's a lot of like trial and error. You're experimenting with it. You don't know what the correct names are. There's a lot of stuff you have to figure out. So this tool really helps get that done fast. All right, so we'll break this down. Up here, we're going to inject. Well, let me show you the. Okay. So this is the object. All right, that's not very helpful. All right, so I wanted to show the way Drupal stores their user information. For this one, there's about 20,000 pages of users. There's over 2 million users of Drupal, and you call the API for each page, and it returns you 100 users. So it gives you 100 users per request, and then you just pick out the fields that you want from that. So that's what we're doing here. So these are the dependencies that we need. Requests makes the request to the Drupal API. JSON lets us read that JSON object. TQDM is just a utility here. It lets me know how long, like where in the loop it is. So I'm looping 20,000 times here. It's nerve-wracking without this, because you have no idea when it's going to end. It could be, a week.
And there's no kill button?
There is. I can just press stop here. But just not knowing when it's going to finish is terrible. Datetime lets me work with dates. Data classes we saw earlier is how we're going to store this information. And then CSV lets me work with CSV files. So first we create the object or the blueprint for user. We're going to give it a name, which is going to be a string, and then the date. So Drupal gives you a timestamp for when that user was created, which is, if you've ever seen a timestamp, it's like a 10-digit or like 10 to 15-digit number that you have to convert into a date to get the actual date. So I created that function here, convert datetime, which is going to take that timestamp, and using the datetime module is going to give me day, month, year. So first we create a blank CSV, and this is where we're going to house all the data. So Python lets you, create, edit, write, read CSV files. So first we make it. We're going to give it a CSV file with the username and a creation date as the two columns. And then we're going to loop through all 20,312 pages of the Drupal API. And then So it's 100 users per request. So for each block of 100, it's going to pull each user, and it's going to get their name. It's going to create this object up here with their name and then the created timestamp. And then the last step is to open up that CSV file, add that result, add that new user to the CSV file, and then do it again and again until we've got all of our users. All right, and that's and at the end of it, you have this 2 million row CSV file that we can start cleaning and doing our analysis of. Any questions here about the process? Everybody good?
I guess in the Drupal, in that API, the unique identifier is the username.
That's just the one I chose. There's a lot of options. They track almost everything.
Yeah.
But what I decided to get was the name. But there's node ID, VIDs in there too.
Yeah.
Is there a way to count the number of pages instead of hard keying the 20313?
Yeah. The result object tells you the last page, so you can just grab that last page variable. Yeah. But I knew it beforehand, so
It's easier. Yeah. Gotcha.
okay. So now that we have all of our data, I would show it, but I'll load it so you can see at least what that looks like. So it came out to 66 megabytes of information, which is not that bad. All right, so now we get into our analysis. Let's see if that really, that might take a while. All right, so now we get into our analysis. So this is Pandas. This is what creates this. It's called a data frame, but it's basically a spreadsheet inside the space. So the file is, this is the CSV file that we created before. These are all the dependencies for machine learning later on, which we actually don't even do here, so we don't need any of this. So it's going to create this user's DF, so user's data frame. It's going to read the CSV file, and it'll print the first 5 results here.
What's so your Pandas and Jupyter, but what's NumPy?
Oh, NumPy is a library for math.
NumPy. Okay.
Yeah, there's a. It's useful. I don't use it as much. It's one of the really popular libraries, but I don't use it because I don't do a lot of the statistical mathy analysis.
And you didn't need the date because you converted the date before you put it in CSV.
Yes. Yeah. I got timestamps, and this is what that function did. Yeah. And then for this, so I can't really use this entire thing to chart, or I don't need the date time. All I need is the year. So we're going to use Pandas to get the totals for each year. So we do that with, so first I'm going to remove everything but the year here. So that's what this does. So it's going to go to every single row, and it applies this function to strip everything but the first four characters, which will be the year. And then we get the totals. So we do a group by. So in Pandas group by, you choose a column. So here we're doing creation year, and anything that has a creation year of 2000 is going to get compiled into one row. So here, all this means is for the year 2000, there was 2023 records with that year. So we do that for each one, and that's what our data looks like. All right, but
2002 on there.
It's not in the API for some reason. 2002. 2002 never happened.
They decided not to do it. 2003
came a couple years too late.
So immediately, what's the problem here?
Just to be clear, sorry, really quick question.
Yep.
You're segmenting this by users created per year, not active users per year.
Yeah, it's just creation date.
We're dying.
No.
No. That's not what this.
Hold that thought. Hold that thought.
We've hit our saturation of new users.
Yeah, well, let him go. We're not rolling.
Okay, but so the point here is we're just looking at numbers. So if you showed this to a non-technical person, it's not very user friendly. It's not, it's so what? It's a bunch of numbers. So what we're gonna do next is visualize this so that we can make it a little bit more friendly. So first, what we need to do is we're going to create an array for each one of these years. So we do that. This is that super looper. So it just loops through, creates from 2001 to 2020, creates an object or a list with each one of those. And we're going to remove the year 2002 because that year never happened. And that's what we get. And then we're going to create a new data frame with just the information that we need. And we actually don't need this one because we're not doing machine learning here. So now we have this simple data frame with each of those things. All right, and now this is where we plot. So I use Plotly here. Plotly is I think it started off as a JavaScript library for visualizations, but they've expanded into Python and a couple other languages. All we're doing is we're X and Y from this data frame. We give it a layout, give it a title, name our X and Y axes, and that's what our data looks like. So now this is a much more user-friendly version. We can just glance at it and see, it's definitely dropped off and it's on a decline. But there's a lot of different factors that could influence this.
Yeah, it tells you that it's declined. It doesn't tell you why.
It doesn't tell you why. So, but that's the questioning part. So now the next question could be, what happened during this time? Right? There's a million questions that you can spin off from this one data set.
Yeah.
And then this is just an example of some very basic analysis you can do with pandas. So here, .mean gets the average for all the years. .min and max, we saw that earlier. It gives us the min, lowest, and highest. So on average, it looks like 112,000 new users a year across all of time. And then if we were going to do machine learning, this would be the first step. I had trouble. I kind of stopped it here. But in machine learning, you plot this out. And so this isn't really a linear model because it kind of goes up and then goes down. So you have to use it's called a polynomial regression. It's out of the scope of this talk, let's just say that. All right, so we get that there aren't a lot of new users coming up, right? But this doesn't really tell us how active Drupal is or how active the people in this community are. So what else can we look at? What do you guys think we can look at to
Last login time.
commits?
Or users that have, total number of users that have logged in that year.
Yep, so I thought about that, but they don't track currently active in that way. It doesn't have last logged in, right? And there was a problem with bots in Drupal. So I think there's a period of time when there's a bunch of bots being created.
Do they track deletions of accounts?
Yeah. That's what happened.
Does it? The API, I didn't see any. There was no
What fields are available in API?
Oh, there's a ton. We can. How much time we got?
Downloads.
Oh shoot. Okay, so.
Whether or not Drupal cons in the US.
Price of DrupalCon?
Yeah, there you go.
Price versus length of actual sessions?
So I'll show you change the show to you. Yeah, I'm done. We'll get back to that. So let me move on for a second. But this is what the CSV ended up looking like. Simple. All right. So what I decided to.
Yeah.
So getting the 2 million records here took me 50 to 60 hours. I had to keep it running for about 60 hours to get every single user. So I decided to look at issues, right, commits, and see if there's an even number of that. But there's even more issues here, so I didn't have time to get each one. So what I decided to look at was how many reviewed and approved by the community issues have there been every single year. So that's what I decided to look at next. So that's what we're doing here. We're going to create that same class. This time we're getting the issues. convert date still here, and we just have the node ID, the timestamp for created, and then the status, which we didn't really need. But and then we open and create that file. There's only 149 pages here for those issues, and we ended up with. So there's much less, still quite a bit, I think. Yeah, so there was 3 million? About 7,421 reviewed issues in Drupal in the lifetime of Drupal. So let's go into some analysis there.
And so what's that 306 number that was prefixed before that?
What's that? Where's
So
that?
you were in that user group, so you were saying it was 7,300.
Oh, this is the node ID for the issue.
That's the node ID for issue. Okay.
Yep. And then when it was created. So same thing here. We're gonna run that in, and this gives us sorry. Analyze issue. All right. So this. We'll actually try to do some machine learning here, so we'll need these, but all right, so we kind of follow the same process. We're going to convert that year into 1 year, and this time we have 2004 to 2020, which is 2004 to 2019 because of the way that the range works. Create the year data, and this is what we get. So this is how many, from 2004 to 2019, how many reviewed and approved by the community issues that there have been in Drupal. So this paints a much better picture because it shows that even though there are not as many new users signing up, a lot of work is getting done in the community. And we're on track. So last year there was 1492, and halfway through the year we're about 771. So we're on track to keep improving that. So does that kind of make you feel a little bit better about the first track?
So yeah, I think that there's still, in order to get to a real kind of sense to answering that high level question, there's still like a lot of unknown other questions, such as, you know, can you plot that? Can you plot that user creation date and tie that to like monthly spikes during the year? Like if there was like a known historical event that we could plot something to be able to like, oh yeah, I can actually see that there's a correlation between, oh yeah, we knew there was like a hack or a big amount of bots coming in this day.
So I actually thought about like searching news for those years with Drupal mentions in it and seeing if there's anything.
Well, not even Drupal, just other parts of the web too.
Yeah?
Release of
Yeah, like the growth of other frameworks.
HTML5, things like that.
Yeah.
We're talking about why 2018 is so high.
Oh, we're talking about just getting a better...
First meeting, 2018 was high.
2018, yeah. So yeah, why did, any ideas why 2018 was such a good year?
People finally...
Because this year isn't done yet?
2018.
Oh, that's true. That's true.
The jump.
We don't know how big 2019
Yeah.
Like, why was there such a big jump here?
Yeah, there's a
From 27.
Because
Because
it's
it's a trend up.
50% increase.
Because
from
people finally started
27
stopping
to
to
like-
Yeah, because
Yeah, that's a really good
Coming
point.
to Drupal 8 was
It's
Drupal
the
9 coming out.
issue queue that
Right.
happened when the adoption of Drupal 8 came
Right.
on. Like,
Uh,
that just skyrocketed.
Yeah.
Okay.
I think that's the 2000.
But it's all speculation until we look at the data.
Yep. And that's what we're here. So,
That's
so we're
true,
gonna...
yeah. Can you pull the tags out of what these issues were?
Yeah.
Yeah.
You could add the,
Everything.
yeah, you could add these 78 and then.
Could you like text mine these issues?
Do what?
Could you like mine do like natural language processing on like, could you get like.
For what purpose? Because it's got
Like right now we have like just,
the node
issue
ID.
ID or
Right.
whatever, but could you also like get.
Yeah, the API gives you the title of the issue, all the comments.
Yeah.
Those common words would be interesting.
Yeah.
will be
Preposition.
Number two.
No preposition.
Number 2 is help.
Alright. So we're gonna
Would be interesting if there's
there's a particular component that suddenly had a lot of issues.
So
Right.
isn't that when people started gaming it to try to get higher?
Yeah. I mean, if you could throw it into something like IBM, which will analyze tone and things of that nature too.
There's
that'd be
a
interesting.
sentiment
If there was a
analyzer.
shift in like people being angry about it, there'll be a lot of interest.
I've worked with a sentiment analyzer, which takes text and tells you if it's positive, negative, or neutral. So that'd be interesting to do.
Yeah, IBM will go even further than that.
Mhm.
It'll like put real emotions, like happy, fun, arrogant, things like that.
Everything in the Drupal issue queue is arrogant.
So maybe pull that one out.
Yeah. All right. So let's try to do some machine learning on this.
Okay.
So this is a little bit more linear, right? And with machine learning, all you're doing is, you remember high school, y equals mx plus b, what that line looks like? So that's all machine learning algorithms do. You create a model which makes a line that is as close to this data set as possible without being too, they call it overfitting, which means that you're too close to your data set and that if new data comes in, your model can't really handle that and it'll give you inaccurate data.
Yeah.
So, that doesn't look right. That doesn't look right.
Oh, this does export an R value too. Good.
Yeah, there's the definitely give these stats. So that's weird. Okay, I seem to have lost the one that I did on this.
Yeah, the analyze issue.
Yeah, but it's
Was it because you pulled out some of the machine learning stuff from the other ones? Were they like dependent on that?
no, I did like a really basic one for issues, but I must have.
You need to run it, or?
Oh, well, I have. Okay, it was on this one. Yeah, here we go. Okay. So here, this is where we create our model, and we're using linear regression. So this chart is basically a line. So if you put a line here, it should cover, minus that one outlier, you should be able to get pretty close. So we're going to create our model. We're going to feed it our x and y values that we made here. So x in this case is the year, y is the total. So we're looking at the relationship between the year and the total number of new issues for that year. So you feed that in, it's going to learn. We're going to do the min and max. So we're basically trying to create our model line here. So this is what we came up with, and then we scatter it. So x, so this is our values, and then the red line is our model. So you can see like our model kind of covers all of our data points, but it might be a little too close here.
Should you
Sorry, actual
exclude
values.
2019 since 2019 is not all the way done?
I didn't exclude it here, which probably would have made this a little bit better.
Yeah, that's
True.
Yeah, but this is, yeah, it definitely influences it. But this is, so this is, I ran into the problem of overfitting here. So my model is too closely related to the data, so it doesn't react to, the new years. And the point of this was to try to predict the next 5 years. So I created a range here for the next 5 years, and then model.predict is, it takes our model, you feed in new, the next few years, and it's going to return what that estimated number of issues. So how many issues are we going to fix in the next few years? So that's what these red lines are, and then the blues are real data, red is our predicted data. So, not that useful, but hopefully like it gives you guys an idea of Python, just install this and you can get this running,
So by 2025, we'll be at 2018 numbers.
We'll be, yeah.
So I have a question just on the structure. So you've got like, this is 31 cells. So each cell in there, you change this, hit run, and it just runs everything else.
So
it's just taking these and.
So 31 is the order. So it's not 31 cells, but it records the order of your cells. So this is the 31st thing that I've run.
And so when you you know, if you've got the same thing running and you had to do like 6 analysis on your site,
Right.
and you've got your books up, if you just target a different data set, you can pop this in Jupyter Notebook and run from there.
Yeah. And like, so if I run something up here, it overwrites whatever's down here.
Okay.
Yeah. That's a really useful, I mean, it's good for data exploration. Like any kind of exploration task, it's really good for that. But it's not really a good production tool. There's a lot of, there's no like linting, it can make you sloppy. But I think it's a really useful tool. And this slideshow this is actually built off of Drupal or Jupyter Notebooks. So it's an extension, and all my slides are in a notebook just like this.
Okay.
Yeah, pretty useful. And there's a thing where I could run cells inside my presentation, but that was too buggy and slow to attempt here. But I'm gonna save it.
So what other IDEs or platforms do you like?
So I use Microsoft, I use VS Code. Yeah, that's what I learned on. But I'm in Jupyter Notebooks a lot more, most of the time.
You have one from JetBrains too, was PyCharm. It's free for the community, or you can pay for it if you have more features.
What's that?
PyCharm by JetBrains. What PHP Storm.
Any other questions? Comments?
Good job, Will.
Yeah.
Thank you guys.